I mean, that saved me recording another lecture on my free time. Okay. Now finally I got to my PowerPoint lectures. Before I start the lecture, anyone has any question, problem from the previous session or sessions in general? Good? Okay. So you have your homework 13 due tonight as a reminder. And after you're done with this homework, you have one more homework, one more quiz, one exam, and our final exam. So make sure to just do them, because if you miss some points, you can easily make up for those by extra credit assignments. But if you don't do your quiz and then you need like 40 points, it's pretty difficult to make up for that by like tutoring or like office hours and all that. So before I started my lecture for my 101 class, I was trying to encourage them to study, and I talked about some salary stuff, and all of them were so surprised, and I was so surprised that they were surprised. So I thought it's good to also talk about that in this class to show you the importance of going to college and also potentially have a higher level degree. So can anyone tell me what is minimum wage in Idaho? Most students know the answer to this question, but can anyone tell me what is an hourly based salary for a scientist? Any guess? So $7.25 is for someone that they don't have any skills or they don't have any college degree. But what is it when someone has a scientist role? What is that hourly based salary? Any guess? 25, what else? 32, what else? So I'm talking about my personal experience, my degree, and people that I know, okay? So this number can be different, like as your friend said, it can be 30, but it can also be $60 an hour. I have a friend that he started after he finished our PhD, he started with $60 an hour. And I was working, I was searching for jobs, still I didn't find a job at the time, and then I was just tired of applying and not having a job, so I decided to just get a job. And I had a job at a movie theater, which was paying $8.25, and salary of me working like one day was 1 hour of his. And my own salary before, being here, it was like $45 an hour. So what I'm saying is that these numbers are different, but what I wrote here is based on personal experience that I have. And if you're working in a work that it doesn't need any college degree, so basically everyone can do that, the minimum wage would be depending on your work, whether it's like state or like whether you work at Walmart or like something that is like, state or nationwide. It can be different, but roughly you'll earn $20K per year. But when you get your bachelor's degree, your salary starts from $60K. And again, depending on the major, that can be like 55 or it can be 65. It is different. I'm talking about like my major. I studied chemical engineering. So in my field, usually it starts at 60K. And all of my friends that we were in college now, they're working in pharmaceutical industries that they pay really a lot. And they started with like 100K. So what I'm saying is that, as I said, and I experienced that in this class too, I feel like maybe, most of you didn't have someone to tell you this. That's why people don't like to study, or they think that they should earn money to pay for their college. But when you get your degree, you can easily pay off your loans or whatever afterwards, because you're gonna get paid much more. So don't let your work or other obligations or like having fun or whatever interferes with your college. That is the most important thing, okay? Try to get your degrees and potentially, try to have like advanced degree to increase your salary. And I always tell my students that I deeply care about them. I care them more than themselves. And I always tell them that I'm their best friend, because sometimes your friends, they try to dissuade you from studying, or like try to, you know, distract you. But the way to success and having a comfortable life is to finishing your degree and getting a good job. Any question about this? As I said, this was something side note. I thought that someone should tell you that in case you didn't know, and some of you might have know that. No questions? Okay, so we talked about alcohols and phenols, and this session I'm going to more talk about alcohols and phenols, and also start talking about thiols. And as I told you, I'm not going to cover the whole chapter, and I explicitly tell you which parts I'm covering so you can study your book, and also I included screenshots of your book in the slides to make sure all of you study them. And I'd rather you have some understanding of organic compounds compared to just talk about one specific type of compound really in detail. And anytime you have any questions, just let me know. So before I start talking about basic properties of alcohols and phenols, I'm going to have some terminology. And I briefly mentioned previously when I wrote H3O plus, and I called that hydronium ion. I didn't write that, and at this point I'm glad I didn't, because the IUPAC preferred name of hydronium is oxonium. And here I have like this website that I didn't have space to include at the bottom of the page, so I included that at the top of the page. So in general, oxonium ion is any oxygen cation that it has three chemical bonds and is attached to 3 other elements or groups. Okay? For instance, one example, as we talked about, is H3O plus. So in general, if you have, again, oxygen cation, so it should have positive charge that is attached to 3, it has basically 3 chemical bonds, okay? And as I mentioned, the IUPAC recommends the term oxonium or hydroxonium for H3O plus. But hydronium is like the common name. So if you say hydronium, that is not wrong either. As I said, we have like several terminologies and things to just remember. So we're studying organic chemistry, right? There are lots of them. So just remember this terminology. And as I mentioned before in the previous class, to help all of you to get A's and B's, and for those of you who are doing really bad in the class, to help you to pass the class, I have extra credit assignments at the end of each lecture. As long as you listen to me and ask me questions, if you have any, you can easily answer the questions at the end. Okay? So make sure that you understand everything that I'm talking about. Any question? Good? So just remembering the name, oxonium ion. So now I'm going to talk about basicity of alcohols and phenols. In the previous session, I told you that alcohols can be considered being acids, right? Because they have a hydrogen that they can lose. But in this session, I'm going to talk about their basicity. Can anyone tell me what we call the compounds that can be both acids and bases? What did we call them? Amphoterics, remember? And we said they have amphoteric properties. And we said if we have compounds that they have amphoteric properties, if they are in the presence of an acid that is stronger than them, they act as a base. If they are at proximity of bases that are stronger than themselves, they act as an acid. So they can be acids or bases. Okay? And you should also remember that alcohols and phenols function not only as weak acids, but also as weak bases. And how I change this in exam, I say alcohols and phenols function not only as a strong acid, but also as weak bases. True or false? False, right? So any sentence that you see that I wrote it for a reason, to emphasize that you should know that, okay? And make sure you understand everything that I'm writing, and then ask yourself, how can I change it? Because sometimes in exam, you read a sentence, it seems that you saw it before, but I trick you, okay? So make sure that you pay attention when you read, okay? And as you can see here, I have like a structure of an alcohol, right? And do you see these unshared electron pairs, right? So because alcohol has these unshared electron pairs, can it be based on that? Can it be an acid or a base? Because it has unshared electrons. It's a base, right? Right? Lewis space. Do you remember what was the definition of a Lewis space? Exactly, it had donate electron pairs. What was acid, Lewis acid? Accept, right? What was Bronsted-Lowry's acid? Donate what?
Donate protons.
Exactly, donate protons. What about Bronsted-Lowry bases? Accepts protons, okay? And also remember, when you have HCl, it has a proton, right, H+. It can donate, that is Bronsted-Lowry's acid. And when it donates protons, it's equivalent to accepting electrons. So it would be Lewis acid. Okay, any questions so far? Good. And they can be protonated by strong acids. Remember, they should be in the presence of acids and stronger than themselves to be bases. We're talking about alcohols, right? So if they are in the presence of strong bases, would they be acting as an acid or a base? Exactly. So remember, amphoteric compounds, if they are in the presence of strong acids, they act as a base. If they are in the presence of strong bases, they act as an acid. Okay, that's what amphoteric means. And I just talked with you about oxonium ion, and now here I'm telling you that the equivalent of oxonium ion is alkyl oxonium ion. And what is that is the following. If you have an alcohol and that reacts with proton, right? So what happens is that this oxygen bonds with this hydrogen here, right? And you should always, when you write a chemical reaction in general, you should make sure that the charges are also balanced. So you have a positive charge here. So here, your product would also have a positive charge, right? And also you add basically this hydrogen here to this oxygen here. Does that make sense to everyone? And we call this ion here, or cation here, alkyl oxonium. So alkyl oxonium is the product of an addition of proton to an alcohol. Or you can just write this sentence here, that if, we have an alcohol that can be protonated by strong acids. Okay, so this hydrogen here came from a strong acid. For instance, if you have HCl, it has proton and chloride, right? If you have HCl, can everyone see that color? Probably. That's a poor choice. Okay, if you have HCl, you have H plus and Cl minus, right? So this hydrogen here comes from a strong acid. And remember, when we have an acid, it dissociates in water to its constituent ions, right? Basically, proton and Cl minus, right? And stronger the acid, you have more of H plus in water, remember? So this hydrogen that this proton that we write here comes from dissociation of an acid in water. Good. So they, and it just refers to what we're talking about here, right? Alcohols. Alcohols can be protonated by strong acids. The product is alkyl oxonium ion. Does that make sense to everyone? Any questions? Okay, so this is one of the questions that I asked you at the end of the class. So if you just learned this, you can easily answer that. Okay? Any questions? Okay. So this is the amount that I'm going to talk about acids and bases and acidity and basicity of alcohols and phenols. Now, I'm going to talk about thiols. So I had the title every session, but I didn't talk about it. So now, here we go. So if you look at the periodic table, you see oxygen, and in alcohols, we had OH, right? So what is below oxygen in periodic table? Sulfur, right? So if you have an alcohol, but instead of O, you have an S, you call that compound thiols. In other words, sulfur is immediately beneath oxygen in the periodic table and can often take its place in organic structures. And this SH group, remember we had like OH group in alcohols. And then the SH group, we call that sulfhydryl. You probably pronounce better than me, but this is how we call that, okay? So this sulf comes from sulfur and then hydryl for that H, okay? And so this SH group, remember, we call that sulfhydryl group, and is the functional group of thiols. So in your exam, any part of this I can give, blank, and I say fill in the blank with the correct word. This one, thiols, So make sure that you know. I mean, if you read this and then learn this, I feel like our exam would be pretty easy, right? But if you don't study, I mean, how do you know what we call that, right? These are all the things that we agree to call these compounds. That's why it's important for you to study. Sulfhydryl. Any question? Good? Oh. Now I'm going to tell you that sometimes we call thiols mercaptans. So this is their other name, right? So most of the compounds that we have in chemistry, like hydronium, like and oxonium, right? They have like different names, and we talked about them in the class too, right? So thiols are also called mercaptans. And you may ask, and I can ask you, that why do we call them mercaptans? And that is the reason. Because if you have a thiol, remember that we should have an SH group, right? And this R refers to any other substituent. But as long as we have SH, we know that we have a thiol. So if you have a thiol, and then that reacts with mercuric ion, and mercuric ion is mercury that has 2 positive charge. We call that mercuric ion. And if you remember from your chemistry courses, we have like mercury can be having 2 positive charges, and we call that mercury 2, right? We wrote that with Roman numerals. When ions, or specifically cations, could have multiple charges, or we had Hg2 2+, which we called mercury 1, because you have 2 atoms, both of them together have 2 positive charge, so each of them has 1 positive charge. That's why we call that mercury 1. Anyway, that is a side note. Here, if we have a thiol that reacts with mercuric ion, it generates mercury salts. And we call that mercury salt mercaptide. And in general, we put R here so it can be different mercaptides. So that's why here your book wrote a mercaptide. So just like it shows that it's salt that has mercury 2 in it. And that's why we call thiols mercaptans. Any question? And if you want to, know how to write this equation, this is kind of review from Chem 101 or your previous courses that you had. One type of reactions that we had was double displacement, right? So what you do, you switch this R here with, I guess, this RS, let me correct this. So you have this RS here that switch its place with this mercury here. So if you want to write a compound that composed of RS and Hg, so Hg was Hg2 plus, and then RS is basically just negative. So what you do, you put 1 here and then 2 here. So this is how you write RS2 Hg. Okay. Can everyone see that? And also you have here H plus and then Cl minus. So you know how we write these types of compounds. For one positive charge, you have one negative charge. So it would be HCl. So your compound as a whole is neutral. So I don't ask you, too much of these things because that is not the purpose of our course. Writing these reactions. The other reactions that we learned, I'm going to ask you, okay? So when we had substitution, additions, but here specifically, I don't stress too much on this. But you should know why we call these mercaptans and what is mercaptide, okay? But writing this equation, I don't bother you much about it. But I want you to know how to write the reaction. Does that make sense? Any questions? And after you write your compounds, you should also balance the reaction. So here you have 2 RS. That's why we put 2 here. So we have 2 RS as well. And now that I changed the number of hydrogens here, which is 2, I put 2 here. So it would be 2 hydrogens. And Cl automatically is balanced, and the same with Hg. Again, this class assumes that you know what are reactions, how to write them, and how to balance chemical reactions. So that is not the scope of our class, but I want you to know how your book wrote that. Does that make sense? Any questions? Good. Okay. Now we want to learn how to name thiols. Okay. So you have the answer here too, but I always like to ask questions so involve students. What is CH3OH? Methanol. How did you name that? Why isn't it ethanol?
It's 1 carbon.
1 carbon, right? And why didn't I call that, why didn't I call that 1 methanol?
There's only 1 possibility.
1 possibility, right? So when we have OH, we add OL at the end of our compound, and then this here tells us the number of carbons, right? Methane, ethane, propane, butane. Make sure you know all those things. What about this one? How do you name this one? Anyone just read it for me? 1-butanol, right? So you have 4 carbons. Why didn't I say 1, 2, 3, 4? Why didn't I say 4-butanol?
OH
Exactly. We start counting from the carbon that is closest to OH. Okay. So remember, we don't start counting from the ones that is attached to OH. We have a main chain, right? Longest chain that we start, counting carbons, but we start counting from the carbon that is closest to the OH group. So in this case, 1, 2, 3, 4, we call that 1-butanol. Why didn't I say butanol?
More than one possibility.
There are more than one possibility, right? I can also have 2-butanol and so on. Okay? So are we good with naming alcohols? So if you know that, here is simple. So instead of, when you want to name thiols, instead of having OH, you have SH, and you add thiol instead of OL. And as you see, I had to use some Microsoft PowerPoint skills, because when I was spelling that, I dropped the H accidentally, so I figured instead of writing that again in the software, I just add that with Word. So that's why the font is different. Anyway, so we add THIOL, and we had methane as a base name, right? So we have that here too, but we write E here because, you have like a consonant here, right? So this is kind of like more linguistic. So if you write methane thiol and then you don't write the E, I'm not going to be that picky. But technically you should have it because you need a vowel, okay? Any questions? So now, based on how we wrote 1-butanol, how could you write this compound? Instead of OL, you write THIOL, thiol, right? And the rest is the same, but we add, as I said, E here to add a vowel, so we can pronounce it, 1-butane thiol. Any question? This is straightforward. So I asked you a really similar question in your quiz. So if you have questions, just ask me now so I can explain again. Good. Okay. So something, when I was going through the preparation of the lectures, I thought is useful to remind you was different isomers of butyl, right? And also butane as itself. So can anyone tell me what is the difference between butane or normal butane, we call that N-butane, and isobutane? Structure. So the structure, how are they different? So if I tell you draw butane or normal butane, how do you know which one is that? What is the difference?
One has a branch and one doesn't have a branch.
Exactly. So if you have these carbons just attached with each other in a line, and as your friend said, you don't have a branch, you call that normal butane. So you don't have branches, unbranched butane or N-butane. And you can also write the structure like this. We call that a skeletal structure. Okay? But in isobutane or ibutane, we have one of the, you have a branch basically. So you have 3 carbon and then the other one is attached here. So why didn't I write that like this for isobutane? Why didn't I write it like this? Exactly, this is cyclobutane. So there is one other possibility, right? So you have like a straight line or like a ring. So the other one would be isobutane. And we call that isobutane, ibutane, or the IUPAC name, remember? So you have like your longest chain, you start naming the carbons, and then you say, methyl propane. So in this case, you don't have to write 2 because there is only one possibility with isobutane. Okay? But technically, if you write that, that won't be wrong. But I won't give you both in the exam, so you don't have to worry about it. But, and here is the skeletal structure. Any question? So that was more of a review of chapter 2. Good? So now, saying that, and I'm going to use that I wrote there later on as well. So I asked you to just draw. I would ask one of you come to the board, but then I won't be having time for extra credit for all of you. So that's why I just going to explain this. But I asked you to just take a minute to draw the structure before I give you the answer. So you see, what you are struggling with. So I can explain that to you. So first of all, you have mercaptan. What does that tell you? SH. Exactly. So you have a thiol. And you remember that it was an OH, that O was substituted with S. And you have cyclo. What does that tell you? You have a ring, right? And you have hexyl. What does hex tell you? 6. You have 6 carbons, right? Exactly. So you have hexyl. It means that it lacks one hydrogen, right? So if you had cyclohexane, you had like 6 carbons in a ring. All of them had hydrogen. If you eliminate one hydrogen, it would be cyclohexyl. And you attach an SH to your structure, right? So here, and I wrote the steps here too, so it would be easier for us. So I have cyclohexane here, and remember, you have 6 carbons. And sometimes I do that in the exam, that I give you like 4 carbons, right? Or like I wrote this or wrote that. You remember that you should have, or like sometimes 1, 2, 3, 4, 5. You should have 6 carbons. So this is cyclohexane. And then if you drop one of the hydrogens, it would be cyclohexyl. And here that you dropped a hydrogen, we attach an SH group. Okay? And your book wrote this as this. So these two structures that I wrote here, these are the same. Can everyone see that? So you can write CH, you can write CH and then attach SH to it, or write it as this. Both are correct. Any question? Are we comfortable writing this or drawing the structure? Good. Okay, if no question, let me go to this example. Draw the structure for 2 hexane thiol. So what does thiol tell me? SH. What does hexane tell me? I have 6 carbon in my main chain. What is this 2 tells me? Exactly, on the second carbon I have SH, right? So here I have the answer for you. So thiol is SH, and then you can write 2 hexanol and then substitute the OH with SH. So this would be 2 hexane thiol. Good? So what about this? Isobutyl mercaptan. And that's why I reviewed butane and isobutane. So you remember what was the difference, right? I just wait 1 minute for you to try to draw the structure before I give you the answer. So this is isobutane, right? And it doesn't matter if you have like this CH3 here, and then have this hydrogen here. Anyhow that you have the structure, right, rotated, your paper or like the screen of the iPad, it would be the same, right? So I wrote it here for the better demonstration of what I want to say. So remember that you could have, based on isobutane, if depending on which hydrogen you would remove, you would have two different alkyls, okay? So two different butyls. So if you remove the hydrogen from one of the CH3s and you have CH2 here, we call that isobutyl, okay? But if you remove the hydrogen, I'm trying to find the same color that I have here. If you remove this hydrogen here, we call that tertiary butyl or tert butyl. And the reason that we call that tertiary is that the carbon that is directly attached to the parent chain, right, has 3 carbons coming out of it within the substituent. So that's why we call that tert butyl. Any question? And that is again review of chapter 2. We talked about like sec butyl, butyl, isobutyl. Remember those things? So here is kind of review. If you remember, that was isobutane. And if you remember, if we remove this hydrogen here, we have tert butyl. But if we remove one of the hydrogens of methyls or CH3s, we have isobutyl. So you should remember that. So now you know what is isobutyl. So how can you draw isobutyl mercaptan? You add an SH to it, right? When you do that, you have, again, isobutyl. And didn't mean to cross that. Okay, right? This is your isobutyl. You attach mercaptan, SH, to it. So that would be isobutyl mercaptan. Any question? So if I tell you to write tert butyl mercaptan, you should also be able to do. Good? Good? Okay. So as I said, I also included your book to make sure all of you know the materials and have, resources to study. Because sometimes, and I had your friends telling me that when they read the book, they learn much better, and that's why I had the textbook mandatory. Anyway, so anything that I talked about, I have the equivalent of the portions that I talked about in the class on the slides too. And also when I was, looking at your book, I was thinking of extra resources to help you learn things. And then I found this video that I thought was interesting, naming thiols. So I also included the PowerPoint, kind of like a screenshot here, so you have like more examples to walk through. So I encourage you to watch the video, and it's just 6 minutes and a half. And here is the link. Also, this guy has like another example here for a compound that has both alcohol and mercaptan or thiol. So I encourage you to also look at that and ask me if you have any questions, so we can talk about that in the class. But obviously I don't have time to play the video in the class. Okay, and here is the part that I talked about butyl and the different isomers that we have in butyl and also butane. So this is the corresponding corresponding portion of chapter 2 that I talked about. Again, I included the book, so I make sure all of you have the resource and know that what was isobutyl, what was butyl. And also, I talked about tert butyl as well. And then here you had sec butyl too, that this carbon, was attached to 2 different carbons. Here we call that sec butyl. But sec butyl comes from butane. Okay? And these 2 come from isobutane. Okay, that's why these are linear, right? These are branched. So make sure to just go back, study, or just like refer to the slide that make sure that you know everything. Okay? So this part again is from chapter 2. And also this part that I talked about styles, I also included your book that I make sure that you know where to study. Any questions? Good. Okay, so I asked all of you, I thought to save some paper, I have your questions like this, and I asked you to just grab a piece of paper and write your name first and the answers. And if you don't have a paper, I brought a notebook so you can just like get one paper from this notebook that I have here.
Thank you.
Of course. And for people who are watching at home, you're welcome to also send me the answers via email. Or maybe I ask you, just reach out to me and I talk about how you can make up for the extra credit points, I guess. And if you are in the class, I expect you to give me the answers, okay? I have some students that they email me, they were in the class, but they didn't give me the for my other class. So make sure to give me the answer to the questions before leaving the class for the extra credit points. And I had some issues with my email from 6 p.m. yesterday that I think my account, someone was trying to hack my account and university blocked my account, so I didn't have access to my email. After this class, I'm going to go to IT help desk and resolve that. So if you send me an email after 6 p.m. yesterday and I didn't respond, that's the reason. But hopefully I'll have my email back in like few hours and then I respond back to you. Thank you. Make sure you have your names. If you didn't write your name, just write it right now. Thank you.
That's our attendance
No.
for tonight.
What's that?
That's our attendance for tonight.
Yes. Thank you.
You're welcome.